Now, today we'll start the next chapter, that is hydrogen. It's a very interesting chapter, hydrogen. Now, hydrogen was first of all detected by a scientist whose name is Paracelsus. Paracalsus. Paracelsus. He first detected hydrogen. Got it? Now, during that particular time, Robert Boyle, he prepared hydrogen by reacting with dilute sulfuric acid along with iron. When iron reacts with Fe plus H2SO4, give FeSO4 plus hydrogen gas. In this way, he prepared what you can say Robert Boyle first by reacting dilute sulfuric acid with iron. We can say that. Clear? Later on, Henry Cavendish, he prepared hydrogen by reacting dilute hydrochloric acid with zinc. And looking at the properties of its inflammable nature, he called it as an inflammable air. Alright, looking at the properties, hydrogen is highly inflammable nature, remember it, it's highly inflammable, the gases. Got it? And it burns in air and vigorously, and it is highly inflammable, it is explosive. So looking at this particular nature, he called this as inflammable air, so to say. Now this is what you can say is that Henry Cavendish said it around 17th century and Robert Boyle said it around in 16th century. Now at that time only, after a few years, that is Anthony Lavoisier. You must be knowing that Anthony Lavoisier has gave the name of many of the elements. Or somebody else discovered, but he gave the name of those particular elements. So Anthony Lavoisier around 17, I'm not sure about the date, but it's around 1780 I can say that. Around that particular. So he what you can say called this particular gas as hydrogen. It has come from the what you can say Latin word where hydra means water and gen means it is forming. Alright, that means we can say the one which makes hydrogen or one which forms hydrogen. For that reason, hydrogen is otherwise known as water former in Latin language. Why it is called as water former? Because Lavoisier studied that when hydrogen reacts with oxygen, it gives, that is, water. Alright, it's an explosive reaction, no doubt about it. When Henry Cavendish studied about it, it's an explosive reaction. It is inflammable in nature. Alright, no doubt about it. But when Lavoisier studied that when hydrogen, this inflammable gas, this explosive gas, when it reacts with oxygen, which is present in the air, it undergoes an explosive reactions. Remember it, hydrogen, oxygen, when it reacts, it undergoes an explosive reaction, whatever it is. But it helps in the formation of water. And hence, in Latin language, hydrogen means water former. I said how it is a water former. Hydra means it is water and gen means it is nothing but former or maker, we can say that. So in this way, hydrogen, the name came into being and we got hydrogen gas in this particular manner, we can say that. Now, you will find that hydrogen is placed in group 1 in our periodic table. Alright, in group 1. Why it is placed in group 1 in the periodic table? Because hydrogen resembles that of alkali metals. It has got the properties, I am going to discuss with you the properties, which resembles that of alkali metals. Alright. Now just one thing I will say you here, that hydrogen has got one electron. Even lithium, sodium, potassium, they have also got one electron in its outermost shell. Alright. If you see the electronic configuration, atomic number of hydrogen is 1, electronic configuration is 1. Lithium, it is 3, so it is 2, 1. Sodium, it is 11, so it is 2, 8, 1. Potassium is 19, so it is 2, 8, 8, 1 in this way. So you have got 1 electrons in the outermost shell. Alright. So what you find is that it resembles that of alkali metal. There are some other also is there characteristics I am going to discuss with you. Just in short I am saying you that why it is placed in group 1. Alright. This is a reason. Now same thing, if you see hydrogen, it resembles the properties of halogens also. Alright, it resembles the properties of halogens also. Hydrogen, we can say that. So it should be placed in group 17. So still today, the position of hydrogen is anomalous. Still today, we are not sure in which position hydrogen must be kept. Alright, rather hydrogen should be kept a special position in the periodic table. Now, how it should be placed in group 17 of the periodic table, just one reason I am giving you. Then I will discuss with you in details about it. So, what you find is that halogens like fluorine, atomic number 9, so 2, 7. Now chlorine, atomic number 17, so it is 287. So it requires one more electron to become stable, to attain the nearest inert gas. Same thing as hydrogen also. It has got one electron, it requires one more electron. Alright, listen carefully here. Hydrogen has got one electron. So it requires just one more electron, one more, just like your halogens. It requires one more electron to become stable, to attain the nearest gas configuration. So by having one electron in the outermost shell, it resembles that of alkali metals. Alright, to get one electron more, to become stable, it resembles halogens also. Alright, so for that particular purpose, what you find is that hydrogen must be kept in group 1 as well as in group 17. So still today I said you, the position of hydrogen is anomalous till today. We are not knowing in which position hydrogen must be kept. Alright, it is debatable, this particular topic is. Alright, it is controversial till the time, from the time of Mendeleev, it is controversial. Still today it is anomalous, I am saying we are not sure. Alright, that in which position hydrogen must be kept. Now, next is hydrogen we are getting in the free state as well as in the combined state you are getting hydrogen. Now, hydrogen is the most abundant element in the universe, you must be knowing it. About half of the mass of the sun and stars is due to hydrogen. Half of the mass of the sun and stars. You know that, you will be studying in the higher classes, that it undergoes in the sun and the stars, nuclear fission reaction it undergoes. Alright, fission and the fusion reactions. Alright, especially nuclear fusion reactions is there, it undergoes there. Clear? So due to which a huge amount of energy is being liberated, we can say that. Clear? So the core of the sun, it contains about 35% and the chromosphere contains about 55% hydrogen by mass. Chromosphere of the sun, we can say that. Clear? The planets Jupiter and Saturn mainly consist of hydrogen. So hydrogen is found in the free state, not only in this, but also the gases coming out from the volcanic eruptions, got it, from the coal mines, the oil wells, all have got free hydrogen. Got it, all they have got free hydrogen in it. Sorry, on Earth, it is present in the combined state. In the Earth, it is present in the form of water, it is present in the form of petroleum, got it, it is present in the form of clay, we can say that. It is present in the tissues of plants and the animals. Alright, it is also present in the form of many carbohydrates. Alright, it is present in the form of many acids. It is present in alkalis. It is present in hydrocarbons. You go on making the list, you will find it that hydrogen is present in combined state as well as in free state. It occurs in the nature. Alright, in combined state it is present in water, the most important. Alkalis, acids, carbohydrates, many carbohydrates are there. Alright, like you will be reading in higher classes like sucrose. Sucrose means cane sugar, from where we are getting the sugar, we can say that. Then fructose, then maltose, then galactose, then lactose, got it, all these are carbohydrates, so to say. So they contain hydrogen in the combined state, we can say that. Similarly, in case of many hydrocarbons like methane, ethane, propane, got it, petroleum, clay, so many in the combined state we are getting it, got it. So in this way, it is the ninth element in the order of abundance in the Earth's crust, we can say that. Clear? So in this way, we are getting hydrogen not only in the free state but also we are getting it in the combined state, we can say that. Clear? Now, next we will come to, you will see the position of hydrogen already I said it is placed in group 1 of the periodic table, you know that, the first position. Group 1, the first position, because atomic number is 1. Its symbol is H, molecular formula is H2, electronic configuration is in front of you. You can say molecular mass is also 1. Got it? Atomic mass is 1, molecular mass is 2, because molecule when I say means it is H2. So molecular mass is 2, but atomic mass is 1 means 1 atom. So it is H. So H means 1. Alright, 1 gram let us say. And when I say that is H2, it is a molecular mass, then it is 2 gram. We can say that. Understood? The difference between the atomic mass and the molecular mass. The valency is also 1 because it has got only 1 electrons in the outermost shell. We can say that. Clear? And it's the first element in the periodic table. So, this all things we knew it. Now, I am going to discuss with you that hydrogen, what you find is that it resembles both alkali metals as well as that is halogens. How it is so? How it resembles both alkali metals as well as halogens, let us see. Now, next is what you find is that hydrogen As I said, it has got one electron in the outermost shell. Hydrogen has got just one electron in the outermost shell. So as hydrogen has got one electron in the outermost shell, just like other alkali metals, so it resembles that of alkali metals. Point number 1. It is a monopositive ion. Now hydrogen will lose an electron. H minus E minus will form H plus. Just like alkali metals, Na minus E minus forms Na plus. Just like alkali metals, hydrogen loses an electron to form a monopositive. Mono means single. Alright, monopositive ion it forms. Alright. Now Na plus, K plus in this way, Li plus in this way. Now it is electropositive in nature. Very clearly you can see it is electropositive in nature. In most of the compounds like water it is electropositive. HCl it is electropositive. Isn't it? Electropositive means what? See, HCl will dissociate to give you what? H plus plus Cl minus. So again it is a positive. It is an electropositive in nature, we can say that. Clear? So and on electrolysis, where you get hydrogen? You get it at the cathode, isn't it? When you go for electrolysis of water. Alright, you go for electrolysis of water, like water gives H plus and OH minus, isn't it? So at cathode, you know that during electrolysis we have got two electrodes. One positive electrode, another is negative electrode. So cathode is the negative electrode and anode is the positive electrode. Listen carefully all of you. When we go for the electrolysis of water, water means it should not be distilled water, because pure water or distilled water, I have said you already, it's a non-conductor of electricity. You have to take here acid related water. That means you have to add some acid to the water. Which acid? Sulfuric acid. We'll add it to the water. Then only the water will become conductive. Then only it is going to conduct electricity. Otherwise pure water does not conduct electricity. So hence, when you take acid related water and you will go for electrolysis, it will dissociate to give H plus and OH minus. These H plus ion will go to cathode. Alright, H plus ion will go to the cathode. So at cathode what will happen? H plus will gain an electron. H plus means what? It is having deficiency of electron. See, it loses an electron to form H plus. That means H plus is having deficiency of electrons. It is going to gain an electron. See, plus. Gain means plus. Electron is negative charge. Alright, so plus minus. It is minus. Plus into minus. It is minus. You know in maths you have studied. Plus into minus is minus. Again I repeat. Minus and here one plus. Then what it will be? Neutral. H. Now H and H. Now H atom is unstable, isn't it? H atom is unstable. H does not exist in the atomic state. Hydrogen does not exist in atomic state. It exists in molecular state. So it combines with another hydrogen atom to form hydrogen molecule. So in this way, during electrolysis, we get hydrogen at the cathode. Just like when other metals, when other metallic compounds undergo electrolysis, other metallic compounds like alkali metallic compounds. I am talking about alkali metals, alright, because I am doing the resemblance with alkali metals. Like sodium chloride, when it is electrolyte, we get sodium at the cathode upon electrolysis. Lithium chloride, molten lithium chloride, molten sodium chloride, molten potassium chloride, you take it. You will be getting lithium, sodium, potassium at the cathode. You will be getting it. Alright? You will be getting it at the cathode. Clear? So in this way, just like alkali metals, as it is electropositive in nature, hydrogen is also electropositive in nature, and during electrolysis, just like alkali metals, hydrogen is also collected at cathode. Okay, hydrogen is also collected at cathode, we can say that. Now, hydrogen has got valency already, I said it has 1, and hence it forms what you can say HCl. You can see here hydrogen valency is 1. When it forms water, valency is 1. Hydrogen valency is 1. Alright, in this way. For that reason only it forms water, isn't it? See here, hydrogen is plus 1 and oxygen minus 2. So crisscross, you know it very simple it is. So it forms H2O in this way. It resembles that of alkali metals whose valency is also 1. Alright, alkali metals has also got valency 1, oxidation state is 1. It has got affinity for non-metals just like alkali metals. It has got affinity for non-metals. See here, it forms HCl where Cl is a non-metal. It forms water where oxygen is a non-metal. It forms H2S, hydrogen sulfide, where sulfur is a non-metal. So it has got affinity for non-metal just like alkali metals. Alkali metals also forms NaCl, Na2O, Na2S. It combines with oxygen, it combines with sulfur, it combines with chlorine, it combines with nitrogen. Got it? In this way. So it has got affinity for non-metals just like alkali metals. It is also showing reducing properties. It also shows the reducing properties. It reduces. How? For example, copper oxide, when it reacts with hydrogen, it forms copper plus water. So here hydrogen acts as a reducing agent. It reduces copper oxide to copper. It reduces copper oxide to copper. Here hydrogen acts as a reducing agent. Similarly, if you take here, that is copper oxide and sodium. Now you know that alkali metals also acts as a strong reducing agent. Alkali metals. If you take here sodium, what is going to form? It is going to form copper plus Na2O. So you take here 2Na. Finish. So just like alkali metals, hydrogen acts as a reducing agent. Here alkali metals also acts as a reducing agent. It reduces copper oxide to copper. Here hydrogen also acts as a reducing agent, which reduces copper oxide to copper. We can say that. Alright. So in this way it resembles that of alkali metals. It has got valency 1, it is electropositive in nature, it forms a monopositive ion, it has got affinity for non-metals. Got it? It has got a valency 1, I told you, then affinity for non-metals, then on the electrolysis it is being collected at the cathode, just like alkali metals, we can say that, and it reduces also oxides just like alkali metals. It acts as a reducing agent. So these are the resemblance of hydrogen with alkali metals. Now we will see the resemblance of hydrogen with halogens. With halogens we will see the resemblance, that how hydrogen, it is similar to that of halogens. Okay. Now let me rub the board first. So hydrogen resemblance that is the halogens. Now I have already said you that in case of electronic configuration, if you write hydrogen has got 1 electron in the outermost shell. 1 electron. Just like halogen has got 7 electrons in the outermost shell. It requires how many more electron halogens? 1 electron more. Similarly, hydrogen also has got 1 electron in the outermost shell. It also requires just 1 more electron to attain the nearest noble gas. So it resembles halogens. Alright? This is one. Its atomicity is 2. Because hydrogen forms H2, just like halogens it forms Cl2, Br2, F2, I2 in this way. Atomicity is 2. Atomicity means number of atoms required to form one molecule of its element. Number of atoms. Here how many atoms is required? 2 atoms. Here also 2, here also 2, here also 2, here also 2. So atomicity of hydrogen is 2. It resembles that of halogens. Because halogens atomicity is 2, isn't it? Atomicity understood. The number of atoms it requires to form one molecule of that particular element. So this is the molecule, na? Chlorine molecule, bromine molecule, fluorine, iodine, hydrogen molecule. So atomicity is 2, we can say that. Now it also forms negative ion. Hydrogen also forms positive ion. In alkali metals we have studied, it also forms negative ion. Alright, hydrogen forms also negative ion, just like halogens. Clear? How? Like you can see, hydrogen it gains, that is what you can say, an electron to form H minus ion. Just like chlorine gains an electron to form Cl minus ion. Fluorine gains an electron to form fluoride ion. Chlorine gains an electron to form chloride. Fluorine gains an electron to form fluoride. Hydrogen gains an electron to form hydride. Alright, how? Hydride, see here, NaH, sodium hydride, CaH2, calcium hydride, KH, potassium hydride. So hydrogen also forms electronegative ion. Alright, just like halogens, it forms electronegative ion, you can say. Clear? So just like halogens, hydrogen is also, in case of this hydride, listen carefully. When you go for electrolysis of this particular hydride, you will get hydrogen at the anode. Isn't it? You will get hydrogen at the anode. Because here hydrogen is negatively charged. So you will get hydrogen at the anode, not at the cathode. Just like halogens. For example, suppose if you go for the electrolysis of sodium chloride. Alright, so Na plus plus Cl minus. So at anode. Anode is with charge, positively charged. So definitely Cl minus will go because oppositely charges attracts. Na plus plus, let me write. Yeah. So at anode, remember cathode is negatively charged electrode and anode is positively charged electrode. So hence it will pull the Cl minus ions. So Cl minus minus E minus. Why minus? Because it has got excess electrons. It is going to lose that electron. So minus into minus it is plus. Minus into minus plus. Plus minus is 0, neutral. So it forms Cl. So Cl plus Cl is Cl2. Why Cl plus Cl? Because chlorine does not exist. I said you just now. It does not exist in the atomic state. It exists in the molecular state. So hence 2 chlorine atom combines to form a molecule. two chlorine atom combines to form a molecule because chlorine does not exist in the atomic state. Same thing will happen if you take here sodium hydride, NaH. It will form Na plus plus H minus. H minus minus E minus will give you H. H plus H will give you H2 at anode. Same thing will happen if you take sodium hydride. Again I repeat, NaH if you take sodium hydride, it will give you Na plus plus H minus. At anode, H minus minus E minus will give you H. H plus H will give you H2. So it resembles that of halogens. Got it? So in case of this hydrides, this if you take the molten hydrides and if you go for electrolysis, then hydrogen will be collected at the anode. Just like molten NaCl if you take, molten it should be, not solid NaCl, because solid NaCl does not conduct electricity. Molten NaCl, sodium chloride if you take it, or potassium chloride if you take, or calcium chloride if, lithium chloride if you take, you will be getting chloride at the anode. Ultimately chlorine gas at the anode you will be getting it. Got it? So in this way, what you find is that it combines with metals, just now I said, to form the respective hydrides. Got it? Clear? So it also combines with non-metals. Got it? It also combines with non-metals. Like halogens combines with the non-metals. Isn't it? Now non-metals means halogens combines with hydrogen to form HCl. That is hydrogen we are talking about. Halogens also combine with oxygen to form the respective, what you can say, oxides, we can say that. Clear? Like halogens combines with silicon to form SiCl4. Halogens combines with carbon to form CCl4. It combines with germanium to form GeCl4. Similarly, as halogens combines with all these elements, silicon, carbon, germanium, similarly hydrogen also will combine. When hydrogen combines with carbon, it forms CH4, methane. Alright, like halogens combines with carbon to form CCl4. Similarly, hydrogen combines with carbon to form methane. Like silicon combines with chlorine to form SiCl4. Similarly, silicon also combines with hydrogen to form SiH4, which is called silane. It also combines with germanium. Same thing. So in this way, it resembles also the halogens. That it forms, it has got electronic configuration of 1, so it requires 1 more electrons. It forms a mononegative ion. It is non-metallic in nature, we can say that. Hydrogen, just like halogens, it is a non-metallic in nature. It's a non-metal, it's a bad conductor of heat and electricity. Hydrogen, just like halogens, it's a non-metal, it does not conduct heat and electricity. It is collected at the anode. If you take the hydrides, the molten hydrides, it's collected at the anode, just like halogens. It combines with the metals, we can say that. Just like halogens, it combines with metals. Yes, sodium, hydrogen, calcium, hydrogen, potassium, hydrogen combines with the metals. We can say that. Similarly, it combines with the non-metals also. Clear? Now, these are the similarities between group 1 elements and group 17 elements. For that reason, I said hydrogen can be placed in group 1 as well as in group 17. Alright, because so you can see so many resemblance are there with group 1 also as well as with group 17 also, with alkali metals also as well as with halogens also. For that reason, you can understand the position of hydrogen is anomalous. But there are certain differences also. Note that differences. Hydrogen has got only one shell. Its atomic number is 1, electronic configuration is 1. But alkali metals had got number of shells. Got it? Alkali metals like sodium 2,1. Alright, it has got 2 shells. Then potassium 2881. Alright, sodium I said 2,1. Lithium it is 2,1. Alright, atomic number 3. Sodium is 281. Potassium is 2881 in this way. So it has got number of shells, but hydrogen has got only 1 shells. Alright, clear? Now, what you find is that oxides of the alkali metals are basic. Like Na2O, K2O, they are basic in nature. Oxides of the halogens are acidic. Like Cl2O, Cl2O3, Cl2O5, Cl2O7, they are all acidic. Alright, listen carefully. Oxides of the metals is Na2O, K2O, all are basic oxide. Basic. Why do we call it as basic? Because it reacts with water to give a base, NaOH, KOH in this way, which turns red litmus blue. Got it? So it is basic. Similarly, that is oxides of the halogens, Cl2O, Cl2O3, Cl2O5, Cl2O7, they are all acidic. Why do you say acidic? Because it reacts with water to produce acids. What is that? HCl, which turns blue litmus red. So, oxides of metals are basic. Oxides of non-metals are, and non-metals means halogens, are acidic. Here metals means alkali metals I mean to say. And here non-metals means halogens I mean to say. It is acidic. But oxides of water, oxides of hydrogen is what? Water, H2O, is neutral in nature. So that's the difference. It is neutral in nature. Got it? In this way, you can find that it is very difficult to decide the exact position of hydrogen in the periodic table. It is anomalous, repeatedly I am saying you. In fact, hydrogen constitutes a separate group in itself. It should be. It should be in separate group in itself and should be assigned a separate position in the periodic table. This is what I say. Alright, it's not written in any book or something like that. This is what I say, that in fact hydrogen should be placed, it should be given a different position, a separate position, and it should be placed in a different group in the periodic table because it has altogether different set of properties. Alright, so this is about your occurrence of hydrogen. This is about your what you can say, the resemblance of hydrogen with alkali metals as well as with halogens, so to say. Alright, clear? So in this way we have just covered up the what I can say in the introduction to this particular chapter. The next we are going to start the preparation of hydrogen. Thank you.